Engineer James Okore, the founder and director of James Okore Technical Institute. Now, in this class, I want to show you how the star delta panel works. When you look at this, you see that this is the diagram of star delta panel. Now, looking at this, you see that we have what we call the power diagram. This is power diagram here. We have what we call the control diagram. This is the control diagram. How does it work? Power diagram will always show you how supply travel from the source, which is the three-phase supply, down to the load, which is this three-phase electrical motor. Alright? This is three-phase motor here. I can just put maybe this to show that it's a motor. Now, when you look at it very well, the control diagram will tell you how you can be able to control the contactors which are being used for this panel, how you can be able to control their coil, and how you can be able to integrate the start push button, the stop push button, the control breaker, and how you can remotely operate it, right? Now, looking at the diagram very well, you will discover that we use three contactors. In star delta panel, we are using three contactors. One contactor is for main contactor, the other contactor is for delta contactor, the other contactor is for star contactor. How does it work? When you look at the star delta panel, you discover that the panel is meant to start the electrical motor, which is three-phase motor, on low speed, which is the star mode. Then after which it will transfer the motor to run on high speed, which is delta mode. Now, two contactors are supposed to be on at once, which might be the main contactor and the star contactor to start the motor to run on low speed, or the main contactor and delta contactor to transfer the motor to work on high speed. The work of the timer, when you look at it, we use timer. The work of the timer here is to transfer the motor from star mode to delta mode at a particular set time. Alright? Looking at the diagram, let me explain the diagram very well. Looking at the diagram, this is 4-pole breaker. And this is the main contactor, this is delta contactor, this is star contactor. Now when you look at this, see that we have overload relay here. Overload relay is always attached to the main contactor. Why? Because if the main contactor is not working, it means that the motor will not work. Now when you look at this very well, you see that this is the control diagram. This is single pole breaker, we are using it for control breaker. This is stop push button, which is normally closed. This is start push button, which is normally open. This is 13 and 14 of the contactor. We call this returning contact, because it's normally open of contactor. When you look at it, you see that this is the coil of the timer, this is the coil of the star contactor, this is the coil of the delta contactor, this is the coil of the main contactor. Let me explain it for you to know how this thing works. Now, when you look at star delta panel, the first thing that we start is the star contactor. Star contactor is the first component that we start. How does it work? When the star contactor starts, the only thing that will happen is that the coil of the star contactor will energize. When the coil of the star contactor is energized, it will shunt these three terminals. That is, it will bring these three terminals, thereby establishing start point. When it establishes start point, the next contactor that will start is the main contactor. The main contactor is the second contactor that will start. And what does it do? It will allow the red, yellow, blue, which is the three-phase supply from the source, to run on U1, V1, W1, making it to work in this point. Because if we have this as 6 terminals of three-phase electrical motor, and we want this to work on star, if you have U1, V1, W1, and U2, V2, W2, it means that you have to shunt this and connect your red, yellow, blue to this U1, V1, W1. So this red, yellow, blue. So if this is to work here, it means that the work of the star is to establish this shunting. And how does it work? It will shunt this point, and this point, thereby allowing this red, yellow, blue that is running on U1, V1, W1 to run on red, yellow, blue to run on what? U1, V1, W1. Then after a particular set time, what the timer will do is that the timer will function, thereby de-energizing the star contactor and energizing the delta contactor. The work of the timer is to de-energize the star contactor and energize the delta contactor. And in this case, when the star contactor is de-energized, this place will release, this place will release, thereby allowing the delta contactor to work. And when the delta contactor is working, it means that the same red phase that is working on U1 will work on V2. The same yellow phase that is working on V1 will work on W2. The same blue phase that is working on W1 will work on U2. Because if you are working on delta configuration, you see that we have 6 terminals here, which is the U1, V1, W1, U2, V2, W2. You see that in delta configuration, you see that this, the coil of this will go to this will go to this, and this will go to this. So when you look at this, you see that this has been established here in a way that the red phase can work on this, yellow phase can work on this, blue phase can work on this, but this is actually the coil of the motor. So looking at it, you see that on delta configuration, the red phase will work on U1, V2, which is red phase working on U1, V2. Then yellow phase will work on V1, W2, which is yellow phase working on U1 and V1, W2. Then blue phase will work on W1, U2, which is blue phase working on W1, U2. So this is how the power diagram of the star delta panel is, and this is how it works. Now look at the control part of it. Let's look at the control part of this, right? Let's look at the control part of this. Now looking at the control part of this, see that we are using the control breaker. The work of this control breaker is for protection against issues that will come to the control part. Now when you look at it, you see that on the control diagram, the start contactor coil and the timer, two of them will like to start at once. Look at it. Immediately you close this breaker, because you see that the neutral, which is the neutral supply, this is the neutral supply, have gone to the neutral part of this coil. Whether the timer, the coil of the star, the coil of the delta, the coil of the main contactor, the neutral have already gone there, alright? Waiting for the live wire to energize each of the coil. So when you look at it, you see that when you close this breaker, current will flow down and pass through this normally closed. Current will stop at this 3 and 13 because they are open. Unless you press them or they are closed, that's when current can flow. Then when current stops here, then if you want to start the motor, which is if you want to start the panel, which is start delta panel, immediately you press this start push button, you have closed it. Immediately you close it, what will happen? Current will flow here, but current will not flow here because this is 13 and 14 of the contactor is still normally open. When current flows here, this is open, it's not going to go any of this delta or main contactor. Current will only flow down through this normally closed and energize the timer coil and the start coil. That's what we make this start contactor to first of all energize. When this timer energizes, what the timer will do is that because you have set it to a particular time frame, so at that point in time it's not going to function. It will wait till the set time. So what will happen is that this start contactor will energize. When the start contactor energizes, the normally close of the start contactor will come to normally open, and the normally open of the start contactor will come to normally close. Since this is the normally open of start contactor, it will close. And since this is the normally open of the since this is the normally open normally close of the start contactor, sorry, it will open up. So it means that these have closed and these have opened up. So since these have opened up, it means that there is no way the delta contactor is going to energize because they are connected in what we call interlock mode. They are interlocked in a way that if the start contactor is working, the delta contactor can never work. So that's the reason why when this start contactor starts working, this delta contactor can never work. So the supply from here can never flow down. Why? Because the start contactor is working and it can de-energize the delta contactor. And because of that, it will establish this bridge. Now when this current flows here, current will also flow and energize the main contactor, thereby causing two contactors to work at a time, meaning that both the start contactor and the main contactor will start to work. Now when this main contactor is energized, it will turn each normally open to close, thereby allowing current to also flow through this point and remain here. Remember, the timer have energized but it has not functioned. Now at a particular time at which you set the timer, if the timer function, what it will do is that it's going to de-energize the coil of this start contactor. Why? Because the normally close of the timer is used to connect the coil of the start contactor. So when the timer energizes, it will turn here to open. When this place is turned to open, what happens? This will de-energize. And when this start is de-energized, all the normally open will return back to normally open, and all the normally close will return back to normally close. Remember, here was normally open before, so it will return back to normally open, and here was normally closed, so it will return back to normally closed. So at this point in time, the current that has flowed through this point will then rush down, thereby making the delta contactor to start working with the main contactor. So in this case, it means that this delta contactor and the main contactor will start working, thereby causing the motor to rotate on a very high speed. So it will continually work this way until you press stop button or until the overload relay trips. So this is how the star delta panel works. Remember, the panel is designed to start the motor on low speed and after which transfer the motor to work on high speed. Why do you need star delta panel? Most of the electrical motors you buy are big motors. Motors start with what we call top current or times 2 or times 3 of its initial current. But because of that, it's discovered that when you start this motor on a very high voltage, it's going to affect other things that are connected on the same bus bar or the same distribution port with it. So because of that, we designed a panel called star delta panel to enable this motor to start on a low speed. At that point in time, the times 2 or times 3 of the initial current, which we call the top current of the motor, will not be felt. And then it will then gradually start, and after which the top current is elapsed or stopped. It means that the motor will transfer and run on a very high speed. So this is how the star delta panel diagram is, and this is how we design star delta panel. Alright, I'm James Ogode, the founder and director of James Ogode Technical Institute. If you want to learn more on automation and industrial control panel, you can register with us at James Ogode Technical Institute, or you can just copy the number you see on the screen now, and then you can call us or you can send us a WhatsApp message. Here at our institute, we teach you how to install solar installation, solar inverter installation, CCTV camera installation, and then we do what we call industrial control panel automation, automatic changeover switches, smart home automation, and everything that concerns electrical wiring, both the domestic, the commercial, the industrial. Alright? So here we do everything practically. You learn it practically, hands-on practical training. Thank you very much, and I'll see you next time in our next video. Thank you.